Today we are breaking down everything that you need to know about the web scraping. We will start with the fundamentals, and then we will cover also everything related to the scraping at scale. So whether you need to monitor some Amazon products listings, or maybe you want to build some other data pipeline, this will hopefully get you covered with scraping itself and scraping at scale. These are really two separate challenges. And the first one is the scraping itself. So whenever you are visiting any page in the internet, something like this, the target resource will be rendering or serving for you the web page in a form of raw HTML markup. This is raw markup, right? So this might contain multiple pictures on the screen. There might be some captions or maybe text, all that. So they will serve it for you from their servers. And on your client machine, on your laptop, you will have a browser as you normally do, and therefore you will see the browser will interpret this HTML and will render it for you on the screen, right? So this is essentially just a single page being rendered on your screen. And whenever you want to do it in an automated way, you would have some sort of an algorithm which can also very well work with this raw HTML, right? It would take this raw markup and it will parse it, right? Essentially what you want to do here is you want to parse this raw HTML. Why would you need to parse it? And this is for you to transform it into some sort of a structured data, for example, into JSON. Or most probably you would like to convert it into some sort of a structured data in your database, which would consist of multiple tables. For example, if you are talking about the Amazon product, there might be like table product, and then there might be different attributes of that product, right? So for example, there might be variations of this product. Then you would have those in different tables, right? So you take whatever HTML markup it is, you parse it, and you store it in a very structured way. So of course, whatever you are scraping, all your final data in the database is just as good as your scraping algorithm here is, right? So your ability to extract the data from unstructured HTML into structured JSON or database entities will grant you with the quality data. This is where all the heavy lifting of data extraction is happening. So that was our challenge 1, our single page data extraction from raw HTML. And really the core here is your algorithm, right? Now imagine you want to do the same thing, not once, but like million times. Maybe it is per product, a million times per product, or every day, maybe multiple times a day. You want to monitor and rescrape the same product, or you just want to scrape millions of products, right? So for example, you have like several products on Amazon or somewhere else, and you just want to scrape them all at once. The thing here is that this is already starting to form our second challenge, which is scraping at scale, right? And if you will start bombarding Amazon with millions of requests from one single laptop, the problem here is that you are doing it with the same IP, and you are doing it with the same browser, which has its own fingerprint, right? So Amazon or any other site which you are targeting, it will quickly detect this, and it will most probably very quickly block you. So this is our second challenge here, right? Scraping millions of pages like this will become problematic regardless of how good your algorithm here is. You might have the best algorithm in the world extracting the data from the specific website, but the real question here in the second challenge is can you really run it a million times for the target website, right? So now let's go to the common challenges related to the scraping, be it at scale or single page data scraping. We will have a look into the challenges and we will find where they belong, basically on one side of the scaling or on the other side of the algorithm complexity. And the first challenge we will talk about is CAPTCHA. Right, you have probably seen a lot of different captchas in the internet. This is normally goes like as a check, prove that you are not a robot, and you are saying, okay, I am not a robot here, right? So whenever some target website like Amazon or any other marketplace or whatever it is detects suspicious activity from your client machine, it might be your machine or it might be automated server, it doesn't matter. Whenever their server will detect any suspicious activity, they will just throw up CAPTCHA to really double confirm, okay, is there a robot or not? And when it comes to CAPTCHA, you have basically two different ways to fight it. The first way is algorithmic way. So you can try to solve CAPTCHA, right, in an automated way. You can do it very well on your local machine. Whenever you are rendering something, you can try to do it like multiple times. And if the first wall you will hit would be CAPTCHA, you would try to improve your algorithm complexity here, and you try to basically solve whatever that is, whatever CAPTCHA is telling you to do. This is option one. You can fight CAPTCHAs by solving them. But this is a never-ending story, really. You'll be fighting the whole teams of developers trying to constantly improve the CAPTCHAs, and that's just never-ending arm race here. And the second option for you is to just never get CAPTCHA, right? So do not do anything suspicious in a way that you never encounter CAPTCHA, or you encounter it as rare as possible. So if you are trying to resolve it algorithmic way, it lands here into challenge one. You are trying to improve your algorithm and really solve it. Or if you are trying to not get CAPTCHAs, this falls into this scaling capabilities of yours. And basically, this means you would try to get unique IPs, or you would try to like rotate your IPs, always change them so that you appear as if you're a legit user, and there would be no reason for the target website to throw CAPTCHA on you. But that's not only like IP address that you might rotate, right? You might also very well change your client browser fingerprint, it's called. This is some unique way to identify your unique client browser, right? So you can rotate that as well. You can change the geolocation of your machine by trying to proxy it somehow. So everything here, really, all the options that you might do are serving one single purpose of you appearing as a unique, legit user to the target platform, so that there would be no reason to hit you with the CAPTCHA. So the best practice solution here for the CAPTCHA challenges is not trying to resolve it here like this, because it's never-ending story, uh, but really shift this challenge to the scalability part of your setup, right? So that whenever you are accessing that website, and you are doing it like thousands of times in parallel, even, you appear as thousands of different unique machines here, each with unique IP address and unique fingerprint of the browser, maybe even from different geolocations, right? So there is no reason to block those requests for the target platform. Now, let's talk about the second challenge here, and that is pagination. Let's put it like this here, and let's put also CAPTCHA like this, and we will land CAPTCHA in here into the scalability, right? Because that's the smart way to resolve the situation and not to fight the complexity of CAPTCHAs themselves. Then we are talking about the pagination. Most of the platforms or marketplaces will not show you all the products at once. They will show you them page by page, maybe 25 products per page or something on those lines. And the pagination challenge is really just algorithmic challenge normally. So you just need a clicker which will go through the pages, and every time you load the page with a lot of products here, this is one single page for you to extract raw HTML from, and then you just click and go to the next one and apply very same algorithm of yours into extracting this data from those pages, right? So pagination is normally just pure algorithmic problem here. And now let's just move it here like this. Now that we know that this is pure algorithmic problem, there are multiple ways to really resolve the pagination issue. You can have like really mechanical clicker here, which will just render the page and click next, next, next. Or you can try to use API intersection here. You can have clicker, right? You can have API interception. What's that is? When the client machine or your laptop requests something from target URL, this is normally just a GET request. And GET request is a part of a mechanism for you to get data from multiple servers. And this GET is actually just a part of the external server API. And you could try to just intercept the logic of how normal browser doing it and just mimic it in your algorithm. And if the GET request or API request has a page component in it, right, you can very well mimic it and have a parameter saying page 1, page 2, page 3, depending on the support of the target API, right? Here you can also have some sort of a browser automation or things like that. This challenge is not really complex here, but you need to keep in mind that depending on the number of interactions you need to do on the pages, for example, if you need to do like 1,000 clicks on one single page, this might very well grow into a scale problem, right? It can have scale component to it because whenever if you will try to spam this or you will try to spam clicks or other interactions to the page, this might very well also hit the rate limits. Normally, though, it is not thousands of interactions that you need to do on the single page after the single raw HTML render to get the data you want. So that is why we will still keep this pagination challenge within this pure algorithmic area of our drawing. Next challenge that we will cover here is blocks by IP address. This is pure scalability problem. If you will try to spam any target website from one single IP, you will get blocked. So you will need to appear as thousands of genuine users making different requests. That's how you not get blocked by IP. You need to rotate them, you need to rotate fingerprints and all that. You cannot solve this challenge with the clever code here alone. You will need some sort of an infrastructure which would rotate the IPs. You could very well rotate the IP addresses and fingerprints on your local machine, but this might be like a couple, maybe dozens of IPs max, after which you will still need a good at-scale infrastructure to be able to really rotate millions of machines or fingerprints, right? So let's put it here as our second challenge. This is IP blocks. This one is a little more nuanced than the previous ones because let's, for example, say that you will be able to mimic like 1,000 different machines, which will all appear to be unique like this. Let's take this small thing. You will have thousands of genuine clients. And then if you want, for example, to scrape the public product pages of Amazon, there will be no issue because each and every machine might just visit a couple of them, then the other machine will visit a couple, and so on. This will appear as a genuine use. Nobody will block you by IP. And even if they will block your IP of one single machine, okay, so what? They will change anyways, and you are not really at any risk here. But this gets a little more tricky when you want to scrape some data which is hidden behind the login wall, right? Something that you need the account to get access to. So these are just public pages, let's say, and there are some pages, for example, which require you to be logged in, right? To have a user. If you try to do it the very same way and provide your account to all these machines, yes, this will be all genuine requests from all these machines, but they will all go through one single gate, per se, through your account. And therefore, Amazon or any other target provider will not need to detect your IP anymore, right? It will not care anymore about these client machines. It will just detect your account, that it is doing some sort of a suspicious activity, like millions of requests from one single account. This is much worse because here you've been risking with just blocking one of the IPs, which you can just change anytime. But here you are risking to get your account blocked, right? And if this is, for example, your Amazon seller account or something like that, this is a pretty big risk going on here, right? You can just lose your account. There is one little nuance to it as well, which is much easier to understand on a simple example. Let's say you want to scrape some products from Amazon, which is, let's take games as an example. Let's say you have some gaming products there, and let's say you have a seller which has like, I don't know, 100 of different products listed on Amazon. You will need a their seller account to go into their Amazon and scrape all those 100 products. And let's say you have an application for those sellers where they might connect their account and provide you with the ability to go into their Amazon account and scrape all these 100 products. Then you will have another account of another seller which decided to join your platform. And then you will take their account, for example, and go to Amazon, scrape their like 20 other products from Amazon, like this, 20 of them. Then you have another user of your application also has joined your app, provided you with the ability to scrape their account, and you go to Amazon, scrape theirs. Having this infrastructure of this army of different unique IPs, right, and different unique machines, you can dedicate or rotate one machine, let's simplify it, like one machine per account, and this will still appear as a genuine use, right? Scraping like 100 products from one single account is not really dramatic here. So you can use one machine, rotate its IP, and use it for one client. The thing here, rotating the IP here and fingerprint, which you should still do, right? You are not avoiding doing the request from this detectable one single account, right? Still. But it's 100 requests, no problem here. Then you are using another account, which is completely separate from the previous one. Again, 20 requests, not big deal here. But say you are not using this account of your users, but if you have some sort of an infrastructure where you are a game publisher, right? Where you connect all these accounts to yours right on Amazon. They are all bound to your account. And you do not really have this access to your account. You only have a god mode admin access to all these accounts, but through yours, right? If this is the case, then be it even the IP rotation here again, right? It doesn't really matter. You are trying to scrape again through one single account, and your publisher account will get blocked very quickly here because you are not anymore doing like 120, 20, and so on separately. If you onboard like 100 users, you are just already doing like 10K requests, right? Through one single account of yours. So we need to distinguish here really how the mechanics of scraping is going on. And keep in mind that IPs are all disposable. You can rotate them, but the accounts are not disposable. If you get the account blocked, this is really a current account. So that is why we will still put the IP blocks into scalability challenge. Of course, there is no way for you to resolve it on algorithmic, but there is this component to it. When you identify yourself as a user, you are getting blocked as a user, not as a client machine anymore. And what you can do here, it's not too much of what you can really do. It's just you need to keep the strategy of doing as few scrapes per account as possible. So do not use these mechanics of publisher account if you need to really do something like that. You need to consider the mechanics where you go a few scrapes per account and not one major account scraping everything. That's it. Let's get to the next challenge here, and that is JavaScript heavy websites. A lot of pages, and this will be a pure algorithmic problem, by the way. This is all about modern websites, right? Most of them will not render the content right away. They will have some sort of a preloaders, maybe lazy loading. For example, in Instagram, you have this infinite feed where you can see a couple of posts here and there, right? And then as you scroll, there will be more and more posts appear on the page. This is one of the examples, right? And the second example, which is much simpler, the page might very well load just as an empty page, and then the actual content will appear in a couple of seconds after preloading. So whenever you extract this raw HTML, it's just empty until you wait a little bit and it will be populated with more and more content, after which you can take it and parse it again with your best algorithm ever here. But you will need to have this waiting logic, or you need to detect that the page has loaded and how it has loaded and stuff like this. So that is why it is pure algorithmic problem here. It has to do with the client machine. Even with the single page scraping, you will need to have this waiting logic and just get this raw HTML somehow. Let's put a couple of other challenges in here just to mention them properly. These are all algorithmic challenges as well, and that is deduplication. You need to understand and plan in advance what is that what you're trying to scrape, how you will store it in the database. For example, if that is a product of some sort, you most probably want to have some SKU or something like this in unique ID. You need to ensure this uniqueness in the database so that you can not only create but update the records. So whenever you are trying to scrape something, try to think what is this identity of whatever you are trying to scrape, right? And in this case, this is SKU, most probably. Then we have error handling, right? This might be very well, a lot of different aspects come into error handling, of course, but here we are talking about HTML markup might change, right? For big marketplaces like Amazon or something similar, it's not happening too often, but it does happen. And if the markup is changing here and you are hard coding the logic, or you're relying on the tag names, for example, it was div tag, and the next day it is p like paragraph, this will just break your extractor if it's not good enough, right? So you need to consider these variations in the logic itself, of course, and you need to have some sort of an error handling, or at least like something that will notify you that it is now broken. Here, there is one modern way to avoid a lot of errors of the markup changes, and that is AI-based extraction, where AI might detect the content on the page regardless of the text, or it can detect what texts are what. We will get back to it a little later, I guess. But just so you know, there are some strategies of neglecting those markup changes with AI here. And of course, there is another challenge here, which is just data quality. Normally, you would see everything rendered on the screen just as plain text, right? But it is not really plain text normally. For some data types, it might be numeric types or something like this. Something might not get rendered at all if it is empty, right? So you need to detect all those cases, and you need to have handlers on different data types, because again, your eventual data here in the database will be just as good as your extractor good here. You need to really pay attention to the data quality, and at least you should know what to expect, right? How accurate your extraction is, and should you really rely on one field or another when you are building the application on top of your database, right? Because you are most probably building some up here. Before we get to the infrastructure options that you might have, I would like to finalize this whole thing with our example here on how you could plan a little the volume of your scripts and how you can assess. You can, of course, see already some numbers here, and we will take the very same example. Let's say your platform is aggregating different games on as a marketplace or something like that, or you are just building a big library of games, something like that. And you will have different publishers connecting their accounts to your application, and they will be saying, say, synchronize my entire library from Amazon or from Steam as a game library, right? They will say sync into example app. This is your application, like example application. And they will click that, and they would expect all their library from Amazon or something appear in your app, right? So let's say you will onboard thousands of different publishers. Each of them will have around 100 games, right? Or 100 products related to that. So here you will have already like 100K initial scripts, right? But that's just per single sync click, right? They click sync, you do 100K scripts if every of your users will click sync, right? But wait, when they will connect all these products, they probably expect you to monitor the changes, right? If they change the title of the product or the price, they would expect your application to catch that change and show the updated pricing, right, in your application. And if you want to do it, for example, daily, this is already by 30 days, let's say, it is 3 million scrapes. So 1,000 users, each with 100 products, 100K daily, right? You have 3 million scrapes per month. Many of users might be not really happy if you will be scraping or updating the data only once a day, right? If you want to do it hourly, you multiply by 24, right? And here you have already 72 million per month, right? This grows quite quickly. And that is only like 1,000 users. If it's a B2C application, it's almost nothing, right? So that is why you need to really plan in advance your scraping capabilities and your scraping infrastructure, because the numbers add up really quickly. And that's only just single page, right? You are lucky if you got all the products listed on one single page. But what if it's paginated, right? You resolve the pagination with your algorithmic approach, yes, but you still need to scrape each and every page, right? Let's say it's 25 here, right, per page, then you have times 4, right? Now let's move to the architecture options you might have here. And the first option, of course, which comes to mind is do-it-yourself setup, DIY setup, let's call it here. And normally this is you just running the browser locally. You can run, it's not just Chrome browser or something like this. This is some browser run programmatically on your local machine, but with some automations which you can do within the browser. So you can use some of the popular libraries to mimic that or run a headless browser on your machine. It might be Puppeteer. This is for Node.js. There might be Playwright for Python and stuff like this. So you basically just program the automations on your local machine, you run them, and what it does is basically under the hood, again, you will not see it, it will open up the browser, and whatever URL you are giving to it, it will just render it, and it will extract the HTML for you from that render. You are basically integrating your algorithm from here into that Puppeteer setup, running and extracting everything here, and you can do whatever you want. It's just programmatic interface here. So this you need to run somewhere, right? And in our DIY setup, where you can run it, of course, you can run it on your local machine. But this would be an equivalent of you almost running just like 20 Chromium browsers, like 20 Chrome browsers. And depending on the power of your laptop, of course, you might handle like 30 here or something like that until you just hit the memory issues and the laptop just dies from too many processes running. One browser is pretty heavy, right? Even if it is headless, it will be pretty heavy process. So your laptop will very quickly just die because of that. But still, you can run that. You can experiment on your extraction algorithm, perfect it for the target website, right? Make it really work. It can even store everything into your database and stuff like this. So you can have a miniature version of your setup, which can be reused in the next level here. Not to the final level. So just be aware of that. We'll get to it in a second. So you can perfect your algorithm here. You can run it on your local machine, but it will be something around like 20 browsers in parallel or in queues, right? Rotating browsers, a browser pool, it's called. So when your laptop is done, like with memory, and you decide to upscale this setup, your first idea here would most probably be to go to the VPS server. This is a cloud server for your algorithm to be hosted there, and this cloud will run for you many instances of Puppeteer, right? Many of browser instances with your script injected in each, right? Or it is more like there is one program running and it is working with all this. But still, you just move your implementation to the external cloud server, and there you will pay for the computational power, right? One of the benefits of the virtual servers of VPS is that you own the entire infrastructure. You don't rely on any third party except for just server provider. They will give you the machine, right? Which is more powerful than your laptop. But there, you are normally paying for CPU, or you maybe have seen it like as a compute hours, something like this. Whenever cloud server is executing whatever you are giving to it, like Puppeteer script to extract data, it will be charging you for the resources, for the computational resources that you're consuming. And this is one of the benefits because normally here you are really paying for what you use, right? But the drawback of that is that, okay, you have your full custom implementation of the hard code algorithm, all that, but now you need to orchestrate all these browsers. Remember, you need like thousands of browsers, maybe like, okay, see, thousands of browsers, rotating the IPs, changing the fingerprints, all that. It will not come out of the box. You will need to run the whole DevOps here to really make it work to achieve this setup, right, where you're rotating IPs and appearing as if you were a genuine user when you are scraping something. So here you just get really just the machine. It's not much different from developing everything locally, except for the fact that it is more powerful than your laptop. Also, when it's coming to this setup and DevOps that you are trying to do here, managing thousands of browsers is not really easy task. As demand grows, you will need to upscale your server, so you will pay more and more for the resources. You will have more expensive servers, and also depending on how good your DevOps here, apart from the algorithm itself, right? How good you are orchestrating those browsers, how you use them to render those pages that you need. This will all add up into your implementation and the infrastructure being efficient or not really efficient. And if it's not, then you will need more computational power and resources, and you need to upscale more. And this will, of course, add up to the bill here. So in terms of the team, also, you will most probably have a developer here working on your best extractor possible, and you will have a DevOps engineer most probably working on all this orchestration for you. So since that is pretty complex setup, there are of course multiple third-party services providing exactly that for exactly and specifically for the scraping purposes. And one of them is browserless. This one was just created with the sole purpose, maybe not so, but for the context of the discussion, they are orchestrating thousands of browsers for you. So they offload all this DevOps work from you. They say, okay, we already have all this set up specifically for scraping. Just give us your algorithm, right? And you will be running already all this out of the box here. And you will give it your extractor algorithm, and your developer here will be working on perfecting this extractor only, and all the DevOps infrastructure will be handled by browserless, right? There are a couple of things which browserless or similar services might not handle for you. Maybe they will in the future. I'm not sure about that. But for example, of course, the algorithm itself, that's already on you. Then CAPTCHA challenges is mostly on you. So what they are doing basically is they're orchestrating the browsers for you, and they giving you those browsers for use. But they do not handle some of the complexities of scraping for you in that sense. And of course, in terms of pricing, this is not cheap service. This is quite expensive as well, because really the most expensive part of the whole scraping at scale is running thousands of browsers. This is very resource consuming, and that's what you pay for. Like even when you go into DIY setup, you are paying for the very same thing, pretty expensive. Like yes, you can drop as you go, but it's still, you need a lot of power to do that. So this was option one, option two of ours, if you go count here. So DIY was option one in that sense. VPS is not really option two because it's the same DIY setup, but you just move your algorithm into cloud server, nothing there. And the option three here is basically having full scale scraping platforms in use. And one of the example is Zeit. There are a couple of others, but this one I'm using quite a lot because they are very developer friendly in terms of their documentation and stuff. And they do have pay as you go plans, which is not really often that you will encounter that. This is also commitment based. So the more you scrape per month, the better your tier is and stuff like this. So what those platforms will provide for you? They will leverage this whole thing for you, the whole DevOps. They will provide you with orchestrations of thousands of browsers, and they will rotate IPs for you. They will also fight the CAPTCHAs for you, and they will also provide you with some of the AI capabilities that I have mentioned somewhere back here, right? So you might even not get to raw HTML at all in some cases. So you can try to describe to AI what to extract from the page, and Zite will return you already the structured response via the API, which you can already very well save into the database. Apart from all this, you will also get, of course, the JavaScript handled for you. And so basically what you will do here is you are sending the URL to Zite. It will return you already structured JSON response of what your extractor would do here. So it's really dramatically decreases the development cost here. Although in reality, in most of my projects, I ended up still building a very good extractor myself here. So really what I would take from Zite is all this leverage of unique machines and scraping in parallel of like thousands of pages. But I would still request a raw HTML from it and still run my own scraper in here so that I do control the algorithm of it. And then when I get my own structured data, I would work with it and I would store it in the database and stuff like this. But the real power of Zite here is that you can just bombard it with millions of requests and it will handle the whole orchestration for you, trying to make all these requests of yours to appear unique and genuine for the target platform. So you request Zite, Zite leverages its own infrastructure, and it will do the request to the target resource on your behalf. It will scrape everything for you, and it will return the raw HTML to you. You might very well configure here like AI module of theirs, which will parse also the HTML into JSON for you. So you get already structured data, almost no code setup here. But yeah, again, in most practical cases, I am doing this, getting raw HTML, parsing it myself. You might very well have a hybrid as well here, because you can make Zite return you HTML, like both HTML and AI extracted data based on your schema, and then you can run an algorithm which would merge whatever AI was able to extract and whatever your algorithm will be able to extract. So maybe even better of both worlds. So in the conclusion, I hope this will help you make a right decision here. First things that you need to think about maybe is what are your actual challenges here, and you need to place them in a good way. So you need to know what is scalability challenge and what is algorithmic complexity challenge. So because this one you can very well develop in parallel to your scalability problem solution, right? Because your developer, one of them, might very well be just working on the best extractor possible, having this DIY setup on their local laptop. Really, there is, if you will go eventually even with this all handling option 3, this algorithm that your developer will be producing, it will still stay intact, right? You still need to extract HTML in the end of the day, and this will not go into a trash. You will be working on this, and in parallel, you will be trying to resolve this scalability challenge. And these are 3 options how you can try to resolve those. Then you need to make proper calculations here to know what to expect, really how many requests, and what are the costs of all these 3 setups based on those numbers. Zite would have a very good calculator for you based on the target platform and how many requests per month you want to commit to. Then in Browserless, they have pricing, I guess, tiered around how many browsers you can run. It doesn't really depend on the complexity of your extractor, because really the browser itself is what's consuming the resources, not the algorithm in most of the cases. So your developer will most probably just confirm it for you. And you just need to know how many different pages and how often you need to scrape, because for all of these pages, you need to somehow maintain the browser running and rendering those for you. So that's how you calculate browserless and similar services. Same goes for VPS. VPS is computational power, right? You need to know how many headless browsers your server should be able to host. And based on that number, you just multiply. Nothing depends on this work, which can be just done in parallel. So you do proper calculations, you assess the costs, and you also need to assess some of the bottleneck cases like this. For example, if you cannot get an access to these client accounts and do few scrapes per account, and you are absolutely forced to scrape everything through your own account, this might very well be just impossible to scrape too often, right? So you need to plan for that. So for the setup like this, you just start in parallel. Maybe you just do a kickstart work and planning just a little to know the actual numbers and if you have the blocking bottlenecks. But after that, you can do these two branches in parallel where you perfect your algorithm on one side and maybe even other developer might be figuring out the scalability part of it for you. And then at some point when this is ready, this guy just gives uh, his results to the other one, and it will be just hosted on whatever scalability setup is produced on the other side. So I hope this was really helpful and not too technical, but if you want me to dive deeper into some tech aspects of any of these options or any aspects of the challenges, just let me know. I will be happy to elaborate on that. Thank you.